a new trend, okay, and it has shown impact in all the engineering branches. So we need to understand much more about this, okay, and this is a matter of molecular scale. So as such, we are going to talk about the yield strength of material and the impact strength and so many other things we are going to study. It is not up to that. It is a scale of nano. Okay, it is a molecular scale. And the molecular level, if you have to do any changes, you need to do at the level of molecular this one level. So it need a specific type of equipment, instruments, and the microscopes to view them. Okay, so many other additional things we need to have to understand this. Okay, and the create see directly this nanometal is not available. Please try to understand directly the synthesized material will not be available. The raw material may be available. By using this raw material, we are going to prepare the nano material, nano composite. Okay, we are going to prepare the nano composite to suit our applications. Maybe it is a medical application, or maybe it is the super elastic materials. Sometimes to create the super elastic materials, when you make it to a very thin wire also, there will not be any problem without having any kind of destruction, which can be elongated. Okay, this is other one property we can find with some of the materials. Those also can be synthesized. Okay, and the nano means what? 10 to the power of minus 9. So we are talking about the 10 to the power minus 9 scale, that is nm, that is nanoscale. So in this nanoscale only we should have to understand how the material behave and what would be the character of the material. And under the magic, what I wanted to tell you here, the nanomaterial, if you have the powder, it may have the different mechanical, electrical, medical application, whatever it is, different properties it may have. When you are going to synthesize the nano composite, what happens? Its behavior it will be different at different temperature, different load, different working conditions. So we need to understand its application to suit the application. What are the changes we need to do with the material, the basic material, how to go for the synthesis. All these we have to show much more importance. Okay. Now the importance of nanotechnology. Importance of nanotechnology. It has shown, as I told you, so many other applications. Here I have made the list of the applications you can see here. Aviation and the space. In the aviation and the space, what we require low the weight composite materials, and there must be improvement in the display of electronic systems, and it has to consume the lower power. Okay, and so many other aspects. Okay, so many other aspects like some kind of physical sensors we required. Okay, and material has to be multifunctional, and it has to be embedded with the sensors. Okay, and some kind of null filters and air purification. For all these, the aviation and the space, this material will be useful. That I have taken slightly to the core of understanding the application of these nanomaterials in the aviation and the space. So I have taken this application in the beginning only, not after studying the characterization and the synthesis of material, because one or the other way one will be having much more interest in this, and they can view through it very seriously to understand depth of a particular application. So that I have taken in the beginning. And if you talk about the chemical industries, this chemical industries, nanomaterial will be used for the chemical compounds in the chemical industries. Okay, and to for the synthesis of electricity in a cheaper way, we can use them in the chemical industries. Okay, and if you talk about the optical industries, even you can see that the nonlinear and photonic and photoelectronic cells and solar cells, the voltaic cells, and so many other the biosensing elements, and even your mobile also, you can see that it looks like a very simple glass. It looks like a glass, and inner components may are not visible to you. So such kind of things also can be done by using the nanomaterials. And solar hydrogen. In solar hydrogen, it is one of the important application. Okay, in production of hydrogen and storage of hydrogen and utilization of hydrogen. Okay, for all these, in the solar cells we are going to use the nanomaterials. Okay, power generation. And in aeronautic industries, as I told you, the aeronautic industries, since the metal is very light in weight. I'm not telling it is a low cost. It is not low cost. It is a light in weight. And for the various applications like the multiple input and multiple output sensor systems, we are going to use. Correct? No, you have already studied the control engineering, such things and sensors and the nanomaterial based composite materials which can be used as a sensors, which can be sensing the wind as a wind sensor or as a photovoltaic sensors or some kind of sensors we can able to develop them by using these nanomaterials. And another one, building and construction industries. In the building and construction industries, it has shown very important this one the application. So in multi-story buildings, they are going up to the 50th floor elevation. So therein the vibration proof and which can able to guard the building against the vibration. For all these, the sensors also can be done by using these nanomaterials. Okay, and one of the I come to know that around 15 years, I think 11 years back, and today what is the position I don't know. We had one very good seminar on these nanomaterials and their applications at MS Rama Institute of Technology, and one can even see that try to find it out from the internet. One of the American-based industry, they are working for a nano thread which is required to be used from Earth to the Moon. Earth to the Moon. So that even to transfer 1 gram of material from Earth to the Moon, it matters a lot. So in between the workstations and laboratories and all, it can be used to lift the materials. That means, as I told you, it can be made into very thin wire, just like to the nano level. If you divide your hair into 100 parts, one part out of which how much the dimension to be having, that kind of material which can able to withstand high load without breaking or without fracture. That is what the kind of nanomaterials we required. Okay, one of the industry they are working on this, the nano threads, the super elastic materials. Some of the industries. So try to go through yourself and find it out what is the condition of it. Okay, and in the fuel, the solar cells and fuel cells. The fuel cells, one of you, if you happen to go to RV college, you can see there one of the laboratory they have opened, which is costing around 2 crore rupees. And today we can find so many the solar panels on the rooftop. So these solar panels have been scaled down to 0.5 scale. That means not even 1 scale. So that means if you can able to grasp the solar power in a 1 meter by 1 meter, the whole effective the solarized power can be obtained in a matter of 1 the 10 mm square the slab of this nanomaterial. You can see that. You can see that a panel which we can able to keep on your nail, that will be having a power which the can able to develop the power from the solar, which will be having the dimension of around by 1 meter by 1 meter. So that is the application of the nanomaterial in the power generation. Okay, as I told you, in the batteries and all, the nanomaterials will be used to increase the efficiency, to increase the power, and to increase the rate of the fuel cell recharging. Even today, you can find the recharging stations. There are also some of the nanomaterial talks are going on. Okay, that is one. And the sensors, as I told you, the nano-based sensors, which will be having different characters, whatever the characters they required, electrically sensitive and electrical, the insulator or the to wetness or even the light, even the insulation, even the resistance, whatever the type of the sensors is required to do, you can able to use them. And even at the grid level to store the instantaneous storage of the electrical power. these nanometals, the nano mesh will be used. That you can find it in the internet. That also you can go through. And the building and construction, as I told you just now, and the pharmaceuticals. So in so many cases like the biomedical applications and all, we can find these nanometer applications, and the consumer electronics and automotive the engineering. Automotive engineering, one of the, anyone can able to tell me in automobiles anywhere you can able to use the nanomaterials for any kind of the application level. Anyone can able to tell me? Can you able to tell me? And you have already seen that there will be a radiator. A radiator, what happens? There will be a secondary cooling and primary cooling. So earlier we were using the water. Today, in place of water, we are going to use the secondary coolant. So this secondary coolant, what happens? Which will be circulated in the engine and it will be extracting the heat. Nominally, it will be dispersed to the atmosphere. But here, what happens? No, there some kind of the sensors at initially, as soon the engine is on, if your circulation is started, what happens? The engine will be cooled down at higher rate. What happens? The thermal efficiency of the engine will come down. Thermal efficiency of the engine will come down. So what happens here? The nano-based valves may be used, which will be very sensitive to particular temperature. Once the temperature of the engine reaches a particular temperature, that time which will be acting like automatic valve, it will open and the secondary coolant will start to circulate in the engine. So this